Hi, everybody. Thanks for joining us today. We'll give about maybe 1 or 2 more minutes, let some folks jump in to the webinar, and then we'll get started. So just sit tight, and we will start here in just a few moments. All right. Well, hello and welcome to the MR4 2025 Summer Release webinar. I really appreciate you all for joining me today. Over the next roughly 45 minutes or so, I'm going to walk you through the powerful new features that we've rolled out in MR4's summer update. We'll talk about why they matter and how they can empower you as Neuraxon users. And then after the presentation, we'll open it up for about 10 to 15 minutes for any questions. And so, yeah, let's get started. So here's what we'll cover today. We'll start with a quick overview of the summer release and set the stage by highlighting our focus, cleaner data, faster workflows, and greater accessibility. From there, we'll do a deep dive into our 3 flagship features for the release. We have Intelligent Drift Stabilization, the Translation Toolbox, and the 3-sensor 10-meter walk test. We'll also take a look at the supporting enhancements. And after all the feature walkthroughs, I'll summarize the key takeaways and reinforce these updates and what they mean for your workflows. And then we'll move on to the most important part, which is the next steps for you. How do you get this release? What can you do with it? And so we'll discuss how to update the summer release, where you can find the tutorials and resources, and of course, how to get support if you need it. And finally, we'll wrap up with an open Q&A session where you can ask anything or share your feedback. So here's what's included in this summer release. So at the core, we've introduced intelligent drift stabilization for reliable drift-free motion capture. We have the Translation Toolbox for generating linear metrics like distance and speed directly inside of MR. We've also added a simplified 3-sensor workflow for gait testing to round out our mobility assessment suite in MR, which includes a ready-to-go protocol and report for the 10-meter walk test. And beyond that, you can analyze loading rate parameters in your preferred units, enjoy a more intuitive powers running assessment workflow, easily import and export protocols and reports, set up multi-level thresholds for data segmentation, use speedometer-style biofeedback for real-time queuing, and even stream playback data into Unity for immersive presentations and visualizations. So each of these improves one aspect of data quality, workflow efficiency, and analytical insight. So let's jump in. This is our first flagship feature. So drift has been the hidden enemy, maybe not so hidden in some cases, but of IMU-based motion capture for years, since its inception. Small orientation errors pile up over time, and especially in long, uncontrolled recordings, and this results in skewed data. And so the usual workarounds are things that we've employed over the years, like reference poses or recalibrations. They disrupt the workflows and I think really just take away from overall user confidence. It makes the use of the system not very practical in some cases. So our mission for the last decade has been to eliminate drift without compromise. So we've been developing, testing, and refining different stabilization techniques to move closer to the goal of long-term drift-free accuracy. And we started with magnetometer-dependent modes, and those, tended to fail near interferences. We moved to a treadmill only or gait optimized approaches. And then we ended up enhancing those with some adaptive logic, and then also added the ability to use the sporadic reference poses. But finally, we've arrived at a real-time, full-body intelligent drift stabilization, which of course is now available in the MR software. So this all wraps up into what we introduced a few years ago as the model optimizer. And the goal of the model optimizer was to unify and apply all these stabilization methods automatically. Since then, it has evolved with each of MR release, gaining intelligence and flexibility and transparency along the way. Early versions automated stabilization with basic fusion and correction tools. And then we added or expanded the capabilities by adding body segment stabilization, advanced functional calibrations, and some additional post-processing refinements. And so this release now culminates with adding the acceleration alignment and some additional adaptive fusion, delivering our most powerful and reliable set of drift stabilization tools to date. The neat thing is by default, all of this runs automatically, but the optimizer also provides full transparency and manual control. And so as you can see, even in the video clip here, in manual mode, you can tune or disable individual settings from fusion profiles to the different stabilization layers, and tailor these corrections to each scenario. Most of the time, probably a vast majority of the time, the automated application is going to suit you well, but there will be situations where maybe some overcorrection is applied in a certain case, or there's a troubleshooting scenario that you need to review with our support team. And so having the ability to tick and change and edit the different stabilization layers allows us to identify, where maybe a problem is underlying, and attack that direct head on. Is it a modeling situation? Is it a environment situation? Is it a hardware situation? But this is a very exciting feature and something that we've spent a lot of time on. Not only just in this particular release. This was actually a feature that got started well over a year ago. But as far as the entirety of the model optimizer, as you can see here, has been a long journey, more or less since we released our first inertial motion capture system, over 10 years ago. So if we step back and look at the bigger picture, why does this matter? And really, it's about confidence. You shouldn't have to worry that your data will drift away over a long session, or that you'll have to stop and recalibrate or take a reference pose, halfway through or intermittently throughout a recording. That type of uncertainty during measurement is stressful for both you and your subjects. And so what do you get? You get a smoother workflow where you can just keep going, whether it's a 30-minute ergonomics trial or a gait analysis session or some research protocol. The data will remain stable and you have super fast processing, and so you'll be able to see those results right away. In practical terms, that means more time spent working with your subjects and less time managing the technology. Now, while intelligent drift stabilization is definitely a huge leap forward, it's important to set realistic expectations. So, first, reference poses are no longer required, but we still recommend them. Doing a quick reference pose at the beginning and the end of the recording, especially long duration recordings, can really improve data quality and unlock the full optimizer toolkit. Second, the acceleration-based alignment does require acceleration to function. So in recordings or for segments where there's very little acceleration, like sometimes on the head or for during long stationary tasks or low velocity activities like even treadmill walking, you may still see some course drift over time. But this limitation mainly affects the arms and the head because the trunk and the legs have additional correction algorithms that keep them stable. So the message here is that our intelligent drift stabilization is a major step forward to drift-free capture, but it isn't magic. And so with a few best practices in place, you'll definitely see outstanding results. And of course, our support team is always here to help guide you in making sure that you can capture the cleanest data possible. So moving on, we also have the Translation Toolbox, and I'm really excited about this feature. I think it's one of the most impactful additions that we made to the MR ecosystem for the motion capture system. So traditionally, our motion capture focused on angular analysis, joint angles, coordination, movement strategy. And that's, what inertial sensors, do well. And of course, that information is valuable, but often users want outcome metrics. How far did someone move? How fast did they run? How high did they jump? And the Translation Toolbox provides access to those translational metrics. Displacement, velocity, speed, distance, all directly within the MR software. And so this bridges the gap between the technical biomechanics and these outcome-based measures that are immediately relevant for researchers as well as clinicians and coaches and patients and athletes. So the toolbox supports three approaches to generate these translational signals. First is strap-down integration, where acceleration is integrated to velocity and then to displacement. This is useful for segment-specific movement, but it requires careful initial conditions and some quality control. Second is a foot-based center of mass motion. And so with one or two foot sensors, MR4 can leverage the contact detection algorithms as well as the integration to estimate horizontal center of mass displacement and speed. And finally, we also have the model-based center of mass motion, which uses the full kinematic model to estimate displacement of the body center of mass utilizing some forward kinematics techniques. And no matter which method is chosen, there are also some drift correction options that are available to be enabled. So you can get reliable translational signals without, additional manual processing. Now, there are a few practical considerations to keep in mind. So initialization matters. Strap-down integration requires periods of rest at the start or end to correctly initialize velocity. Starting and ending the movement interval in the same horizontal and vertical position can also be used to mitigate integration errors. And shorter analysis intervals, under 10 seconds, can help minimize drift, especially for non-foot segments. Now, for the gait and walking tests, we definitely recommend using the foot sensors as they provide the most reliable center of mass estimation. versus the single segment translational data that you would get from the simple strap down integration method. And then as far as calibration is concerned, using the forward lean or the multi-pose calibration, even for a single sensor, can still help stabilize initial course drift in any environment. And one thing I want to note, of course, is that the translation toolbox is not replace the angular analysis, but it complements it by adding these outcome metrics that really help answer functional real-world questions. So how can you apply this in practice? Uh, one of the most compelling examples is vertical jump testing. With a single pelvis sensor, the toolbox produces data to determine jump height and takeoff velocity. These are gold standard measures for lower body power and rehab progress. Beyond jumps, the toolbox makes walking speed measurement super easy. And then with three sensors, the pelvis and both feet, researchers or clinicians can track gait speed, displacement, asymmetry metrics, providing a much more accurate insights than just simple stopwatch-based tests. And for athletes, running analysis is another key use case. MR4 can capture the center of mass displacement, the distance, the changes in the symmetry over time. So perfect for monitoring some return to sport readiness or performance improvements. And other performance measures related to speed or distance can be grabbed and added to reports in just a few button clicks. So one of the examples that was shown here was, doing a overhead press, looking at the hand velocity, which, would equate to the bar speed or the bar velocity during the lift. So any of those types of situations where you're interested in looking at these outcomes in terms of the translation or the speed or the velocity are all now possible through the translation toolbox. And so the takeaway is that these metrics translate complex biomechanics into more clinically and functionally relevant outcomes. So data that you can use. So why does this matter? Because motion data is only valuable really if you can translate it into outcomes that people care about. Angles and waveforms are definitely powerful, but walking speed or jump height speaks directly to the progress and the performance. And so that shift from data to outcomes is what the translation toolbox delivers. And what do you get? You get simplicity. So instead of exporting and processing this data in multiple steps, you can just open MR4, make your measurement, and these results can be available to you in just a couple button clicks. So it frees up your time, makes it easier to communicate with patients or athletes or colleagues who want to see the results that they immediately understand, and gives you a new toolbox to be able to assess motion. Um, so while this is definitely a feature that I would say is a little bit more geared towards some of the advanced users, the workflow and the utility of the feature itself is still pretty easy to operate. But however, what I'm most excited about is getting this out into our user community and seeing all of the creativity that is born from that. What types of measurements are our customers actually performing? What types of analyses are they looking to accomplish with something like the translation toolbox? So this is definitely the first iteration, and I'm really excited to be able to see how this thing grows and expands over time. So next we have the implementation of a timed walk test, or we've actually implemented the 10-meter walk test kind of as the default protocol. And so the 10-meter walk test is, one of the most established mobility assessments in clinical practice. It measures walking speed over a defined 10-meter distance and is used to assess functional mobility, predict fall risk, and track rehab outcomes. Typically, it's conducted with a stopwatch in a hallway or a lab, but now MR brings this validated test into a sensor-based objective format. So MR4 enables the 10-meter walk test performance with just 3 sensors on the upper spine and both feet. And so leveraging the sensor integration, step detection, and some model-based algorithms, we can compute the precise walking speed and distance in addition to several kinematic parameters around the trunk and the feet. And so this streamlined setup retains the test's clinical practicality, but offers a more portable, repeatable, and scalable solution. And of course, with the addition of the 10-meter walk test, we also complete a powerful mobility assessment suite inside of MR. And so users can now perform multiple tests, timed walk, instrumented timed up and go, sit to stand, postural sway assessments, all using just 1 to 3 sensors. And so this positions the MR software as a one-stop platform for all of these mobility evaluations. And one thing to note is that the foundation of this clinical mobility testing is strong. And so the instrumented timed up and go was actually validated recently in this publication by researchers at Wrocław Medical University. And so even with our early generation Neuraxon IMUs, the Research Pro system, the study showed reliable detection of the sit-to-stand, walking, and turning phases, with low variability observed in the key gait parameters among healthy adults. And so this demonstrates that the mobility tests stand on, trustworthy peer-reviewed science. And it was great to be able to see this come out and have it be represented on the timed up and go test, because of course the other mobility assessments essentially are the timed up and go tests, just separated out into their own sequences. So great to be able to see that, and definitely appreciate this group for making this publication, and of course looking to see some more of these get published by you all out there. So kind of following the path here, the same format, why does this matter? The 10-meter walk test, has been a clinical standard for years, but the way that it's usually done, just stopwatch and observation, it leaves a lot of room for inconsistency, and it lacks detail. So instrumenting it, you get to keep the familiarity of the test, but add a level of objectivity and repeatability from the sensor data. And so what do you get? You get a tool that feels approachable but powerful. It takes only 3 sensors. It's fast to set up, and it produces, reliable, trustworthy results. And so that means that you can run this, daily in a clinic or as part of a research study, and know that you're getting meaningful, consistent mobility data. Now, we'll take a jump into some of the other enhancements that were added as part of the 2025 summer release. And so the first one that we'll talk about is that we've added some loading rate parameters to the gait parameter table. So these metrics, they quantify how quickly force is being applied during walking or running, which of course is critical in both injury prevention and performance optimization. You can view both average and instantaneous rates, and even select between units. We've got kilonewtons per second or body weight per second. These parameters are integrated directly into the gait reports generated from the pressure distribution treadmills. And so they provide a more complete picture of the loading mechanics. And so for clinicians, that means better profiling of injury risk and ground reaction strategies. And of course, also very valuable for our research customers as well, looking to see the effects of different interventions on these strategies. So, it's a small addition, but really strengthens the ability to evaluate impact forces with the pressure distribution treadmill data. Another thing you might notice, which is shown in the clip here, is that the user interface has changed a bit for these gait parameters. In previous versions of the MR software, if you double clicked and opened up these tables, it was just a list with some checkboxes next to it, and you could switch between the temporal or the spatial data. And so we shifted this to be a more flexible user interface to allow you to compile the different parameters that are useful to you in one grouping. And so you can see there that you can add, different parameters from the different categories into the same list. Of course, if there's some settings to adjust, for instance, like with the loading rate parameters, you can change those around. Other aspects, of course, is you can add multiple parameters. So for instance, with the loading rate, you could have both of the absolute units and the relative units be displayed inside of your report. So just adding some more flexibility and options for the customization that, of course, we love to explore and expand as part of the MR software. Next, so the Powers running assessment has also received some usability upgrades. So now we automatically score key variables like knee forward over toe and foot pronation. The visual for foot pronation has also been refined for clarity. I'll get my laser pointer out here and see if I can show it to you guys in the video. Right about there, you can see that there was this another line added from the ankle marker up to the back of the knee. So just giving a little bit more of a clear visual as far as what that foot pronation looks like and how it's generated in this 2D format. The crossover sign is also scored automatically, but you still have the ability to override it. So there's some logic built in there to automatically apply that yes or no selection. But of course, you can still click over and use your own interpretation. And then another addition that we made for the markerless workflows is that we've added prompts to correct the pelvic tilt. So just helping ensure accuracy for that metric. And so you'll see here at the kind of back end of this clip where I click in and there's a checkbox there to confirm that parameter. If you don't click that checkbox and you try to proceed, it will give you a little pop-up and just make sure that you understand that you're proceeding without confirming. And the goal here is really just to improve efficiency, reduce some user error, and strengthen the clinical adoption of this assessment. And so, we're very excited to have been working with Dr. Powers on this, and we'll continue to make improvements here in terms of the workflow and other aspects related to the performance of this assessment. Another key improvement for the summer release is around import and export. So you can now export entire applications along with their associated protocols, which makes it so much easier to share complete setups. And then in addition to that, when you export that protocol, if there is a report attached to it or linked to it, that will also be part of that entire export. And so when you import it back or you bring it to another computer, the linked report templates come with it. So you don't have to rebuild or reconfigure your reports every time or go through the additional process of getting to the report selection menu and exporting from there and have kind of multiple steps to be able to configure your software on another workstation. So this means that your workflows can stay consistent across different teams or labs or workstations. And if you develop a great setup in one location, you can easily replicate it anywhere else in just a few clicks. So this one was just all about streamlining and standardizing so that you spend less time on setup and more time collecting and analyzing data. So we've also expanded how thresholds and biofeedback work in MR4. One of the features here is that we have let me turn my laser pointer off. You can now set up to 3 thresholds in the subperiod analysis element, so creating 4 distinct zones. And so this enables, more nuanced classifications, for example, for monitoring fatigue or rehab progression or risk levels. And so this is a feature that is going to be helpful, especially as we kind of migrate into some of these reports where we're really categorizing data and maybe even converting that into some scoring systems and things of that nature. Whoops, there we go. We also introduced a speedometer style biofeedback display. And so this real-time visualization is, an intuitive way for motivating and creating some training environments. Being able to see sort of those threshold zones, where's the risk zone or, the area that you should be targeting, and being able to interact with it in real time, really enhances the visualization, for the biofeedback and kind of the engagement with the data here. And so finally, we've introduced the Unity playback streaming as well. And so this allows you to stream motion data directly into Unity for VR or AR simulations, digital twins, interactive demos. It opens up some new opportunities for ergonomics and education and training, where you can visualize motion that you've collected with the inertial motion capture system in MR in these immersive environments. And so for users exploring applied biomechanics or interactive applications, this bridges MR4 with one of the most widely used, 3D platforms in Unity. So this is another exciting feature that we were looking forward to releasing, just to again kind of see how our user community starts to work with this information. One thing I'll note is that it is playback, so it's not a real-time stream. So you can collect the data in the MR system. Of course, that takes advantage of our full optimizer profile to be able to ensure the data is super clean. And then that stream can be enabled to essentially play back that data from MR in the Unity software. So giving you the ability to, construct and configure, different animations or immersive environments that utilize the MR or the Ultium motion data from the inertial sensors. And then we'll also be looking to add support for EMG data here soon as well. So keep an eye out for that. So to summarize, this release, tackles some big user pain points head on. Drift stabilization is solved, with the new intelligent stabilization tools. Translational outcomes are delivered through the Translation Toolbox. Gait analysis is made accessible with the 3-sensor 10-meter walk test. And we've also added some smarter parameters, improved workflows, richer feedback, and the new immersive integration with Unity. And so all of this, reinforces one of Neuraxon's main goals in software development, which of course is delivering cleaner data, streamlined workflows to all of our users across all the verticals: research, ergonomics, and the clinical and sports markets. So to wrap up, here are some simple next steps that you can start using the summer release right away. So first, you'll want to make sure that your installation is up to date. And if you're curious or not sure, you can check the status of your software maintenance plan on our website to confirm you're eligible for the update. Of course, you can always reach out to the support team or to your account manager as well. Next, I would encourage you to take a look at the release notes and the tutorials that we've created. These will walk you through the new features and give you ideas for how to apply them in your work. If you'd like, you can also download some demo data from our website. And so that's a great way to try out some of these new tools without setting up a full session. And of course, if you run into any questions or need help applying these features in your workflows, our support team is always here to help. And finally, I would say just keep an eye on your email and our social channels for updates, different learning opportunities, and tips for getting the most out of your Naraxon equipment. And before we close, I want to remind you all about a special opportunity coming up next month. And so we'll be hosting our 2025 Naraxon user group meeting here in Phoenix on October 24th and 25th. And so this is a chance to connect directly with our team, hear from our expert speakers, learn how others are using and applying their Naraxon systems in their work. And exciting part is this year we are pairing it with Treating the Injured Runner course, which is led by Dr. Chris Powers and Dr. Irene Davis. And so this is a highly regarded program that brings the cutting edge clinical insights into running mechanics, injury prevention, and rehab. And so together, these two events create a dual weekend experience, one focused on user community and technology, and then, of course, one focused on the clinical application. And so, registration is open, space is limited. So if you haven't signed up yet, definitely go and find that on our website and register soon. And we hope to see you in Phoenix next month. So that brings us to the end of the presentation. We've actually got quite a bit of time left to address some questions. I saw a few come in, but hopefully we've covered all the features and showed you how they can be used and why they would matter. But yeah, I'll go ahead and open it up for some discussion. Looks like there's a few that already came in, so we'll go ahead and jump into it. So first question is, does intelligent drift help with issues related to interference? Great question. Yes, in a way. The simple answer, yes. So basically, the optimizer, model optimizer, which sort of encompasses this, let's say, theme of intelligent drift stabilization, that utilizes a bunch of different techniques for managing gyro drift, magnetic interference, things that would affect the outcomes or the data that's been captured with the inertial motion capture system. But it's a combination of different tools. Additionally, that also takes into account the calibration. So, interference in terms of like magnetic interference, which is what I assume you're referring to, that's actually handled mostly by the calibration side of things. So being able to do those functional calibrations allows us to establish the course plane or the axial plane without having to rely on the magnetometer, which is exactly, that's the issue that you would have in terms of interference. So what that allows us to do is we can set that up, we can define that axial plane using the calibration method itself. And then we can still utilize the magnetometer data when we feel like it's trustworthy. And so that's kind of part of that entire adaptive fusion protocol that's embedded inside of that model optimizer. There's a lot of things going on in the back end where it's looking at all of the raw data components, even things like the activities that are being performed. So a lot of intelligence there in terms of taking the data that you recorded, looking at it backwards and forwards and the raw components and being able to try to make sense of it, in a really, really fast amount of time, really short duration, so that you as the user don't really experience any lag or anything like that. You just get good information on the back end. So again, probably a long-winded answer to your question, but yes, the drift stabilization definitely helps with issues related to interference. And one thing I will note, and maybe this is a question that also has come up, I haven't seen yet, but that tool set, of course, is applicable for data that's been recorded as well. So if you have data that you recorded in, MR 4.0 or even MR3, whether it's with the Ultima Motion system or the legacy systems, once you import that into MR 4.2, you can go in and you can apply those new optimizer settings or that auto optimization actually, and it will help clean up some previously recorded data as well. So definitely something that I would encourage. Let's see here. Can you use the shoe inserts for loading rate parameters? No, not at the moment. So the loading rate parameters are restricted to just the pressure distribution treadmill at the moment. And so that's uh, there's some aspects kind of behind the scenes that make it a little difficult to use with the insoles or with the platform. But definitely is now that we've got this kind of out in the real world, we'll be looking to also add that parameter to those systems as well. Let's see, are there any data that the variables within the power's running cycle are risk factors for injury, or is it meant to be used for running performance efficiency? That's a good question. Realistically, the complete powers running assessment is sort of like a total evaluation of running mechanics. As part of Dr. Power's methodology, he's constructed a scoring system which evaluates the risk profile for all of these different pieces of the running mechanics. Another part of the workflow is actually equating or relating those different mechanics to particular injury profiles as well. And so if your patient comes in and presents with certain symptoms or a certain injury or deficit, Dr. Powers has identified kind of the core list of those injury mechanisms, and if you select those, then the parameters that are going to be evaluated also are filtered based off of the symptoms or the injury profile that's selected during the workflow. So, generally speaking, yes, it's meant to be able to assess, sort of, or rather, classify the running mechanics into these kind of risk categories to highlight, where maybe a more risky area is. But then I would say it can be used to facilitate the running performance side of things as well. By allowing those deficit areas to sort of be highlighted. And so if there are mechanical issues, let's say, that are causing these performance or efficiency issues, those will stand out, and then that can be addressed through whatever intervention or training or strengthening program that might be necessary. And then of course test again and see if you're making that progress. But as part of that, for sure, again, great opportunity coming up in October. Come and hear it from the man himself. He'll be talking all about his approach as well as many other deep dives kind of into treating the injured runner. Okay, this one's got a couple questions, so we'll kind of work through it here. Let's see here. Is there a gauge for how much correction, how aggressive the optimizer is currently applying and warning the optimizer believes the situations require user intervention? Great question. I think this is kind of getting into an area of like, can the system like alert you if there are issues? So at the moment, no, there's no sort of like warnings that are happening necessarily. We do provide some feedback when there are kind of let's say angles that are very far out of biomechanically possible ranges. So that is something of note when you do manipulate some things inside of the optimizer. That is a feedback that is provided. But as far as like giving you warnings about kind of the overall quality of the data in that regard. There isn't anything that's sort of happening in real time regarding that. So the optimizer itself, really just kind of takes and handles all that stuff on the back end, and then gives you, the best possible result it can. The idea of having those manual operations is just to be able to manipulate certain things and kind of turn or tune things off, depending on if you're not interested in having, all these corrections applied. There's certain people that are doing things where they want, more of that raw data. It's a possibility that maybe they want to try and create their own correction algorithms, for instance, on the research side of things. But obviously, from a practical standpoint, just using the automatic application of the optimizer is going to be reliable and be something that you can, trust in to give you some great data. Will pathological conditions like tremors be overcorrected by the algorithms? Great question, but no, all of that should be present. There are sort of a lot of the drift issues are actually like low frequency drift. And so many of the algorithms are kind of tuned to be able to evaluate those pieces. These kind of sporadic movements and things are not really what are affecting the sensor data. So, those pathological conditions won't be like smoothed over or anything like that. It's that's not exactly how things are working with these algorithms. So I wouldn't have any issues or wouldn't worry about that being an issue. Let's see here. What are the gait analysis metrics available from just the foot sensors and IMUs without video camera or the treadmill? So with just the foot sensors, using like the translation toolbox, for instance, you can generate like horizontal distance traveled. You can generate velocity. You can generate gait speed. And so those are all available as part of that translation toolbox. It's also possible to generate the step detection signals, which are, square waves generated from the left and the right feet sensors, which then you can actually use to run a report to get some temporal gait parameters. What is the calculated, like what's the step time or the coordination between stance and swing, for instance, the percentage of those. So those would be available just with the foot sensors. Obviously, if you add the trunk sensor, the upper spine sensor, now you can get into that timed walk analysis. And so that is kind of going to be a more automated protocol that's going to give you not only the temporal gait parameters that I mentioned, but then some additional kinematic variables like foot pitch at toe off, for instance, or your foot pitch speed as you're walking, in addition to some of those translational metrics as well, like walking speed or step time and things like that. Let's see, do you have devices specific for gait analysis? Yes, of course. Many of our devices are used for gait analysis, and we have several of them that are applicable for that, and can be combined or used in singularly. And so I would just encourage you to go onto our website and check out the application page. Click gait analysis, and you'll see the equipment that is recommended for that. And you can explore the other applications as well, from the mobility tests and anything else that is demonstrated there. And if you're interested in anything, just reach out to us at info@neuraxon.com or submit a contact form on the website, and we can get you in touch with the right people to get you pricing and things like that. Let's see here. Can we use it to measure balance ability? I'm not entirely sure what this is related to, but I will comment on the fact that one of the tests that we support within the mobility assessment suite is a sway analysis. And so that's using a single sensor positioned on the pelvis to be able to look at the acceleration profile actually, but that creates a sway pattern that, would mimic a center of pressure pattern. In addition to that, we can look at some additional parameters such as like jerkiness or the smoothness of the sway, the overall distance covered. So those are all metrics that are produced more or less automatically, with the sway analysis that's embedded inside of MR. Of course, we also have the pressure distribution systems or force plate integration as well, which you can actually look at the ability to balance, from the ground reaction force standpoint. Let's see here. We do not have a specific upper spine sensor because we do not have upper body capability yet. Can you replace the upper spine sensor with the lower thoracic sensor as a third sensor to use in 10-meter walk test? So I think for this, what I would say is to just not use the lower thoracic sensor and make that your upper spine sensor. It's not necessary to have the lower thoracic sensor for the spine model. In fact, you can skip that if need be. You can use the pelvis and the upper spine sensor, and that will give you the sort of rigid spine model, what we call you'll see angles on there that are called the torso-pelvic angles. And so if you're looking to complete the 10-meter walk test with kind of a more, let's say, scaled up inertial motion capture system, so like the full lower body plus, some trunk data, you can then run the 10-meter walk test, get those metrics, plus add in all of the, additional angular kinematics, that you would see from the hips or the knees or the ankles, in addition to, of course, all of the metrics that are produced from the 10-meter walk test itself. So yeah, with that, I would say just assign that lower thoracic sensor to the upper spine, and you'll be good to go. All right. And so, I think that's it, unless any other questions come in. Really appreciate the engagement. Some great questions came in, and so I was happy to answer those. Of course, this will be recorded or is being recorded, and so we'll distribute that recording out to all of the registrants. So keep an eye out for that. And until then, again, really appreciate everybody for joining. Don't forget to go and follow us on all of the social media platforms. So at Neuraxon USA. Check out the website. Don't hesitate to reach out to us, and just keep in touch. And we are, planning on, releasing software more or less every quarter, and so, you'll be hearing from me again in the near future. But again, really, appreciate everybody's time and excited to get this one out and start to get some feedback. So, thanks again, and I hope you all have a wonderful rest of the week, and we will see you next time. Thank you.